All right, so today Lainey and I are going to be discussing meats in early childhood. Specifically, we're going to talk about the benefits of meat consumption related to the nutrient composition, so macronutrients, vitamins, and minerals. And then we're going to move towards different concerns with meat consumption related to those nutrients, along with some of the handling and processing and establishing unhealthy eating patterns. And then we'll briefly move to vegetarian diets and how they can be consumed, followed by recommendations for both parents and healthcare professionals, and then conclusions and future research.
Okay, so we're going to start out with just going over what is meat. Meat generally refers to the edible flesh of mammals that's handled and prepared for human consumption. In the United States, though, the broad term of meat can also refer to poultry and sometimes seafood. Meat includes the animal's skeletal muscle and its accompanying fat, as well as other tissues that stay intact with the meat during processing, such as the skin, tendons, ligaments, blood vessels, and bones. Meats are commonly classified based on their muscle fiber myoglobin content. Iron containing myoglobin in skeletal muscle, when it's exposed to oxygen gets converted to oxymyoglobin that has a reddish brown color. And therefore, meat is often referred to as red or white meat. Red meats include beef, pork, sheep, goat, and mammalian game. White meats include chicken, turkey, duck, goose, and wild birds. Um, then processed meats refers to meats that's been altered through smoking, curing, or salting, drying, or has had chemical preservatives added to it. These include hot dogs, sausages, bacon, deli meats, and jerky. For the purpose of this presentation, whenever we say meat, it will refer to beef, pork, chicken, and turkey unless it's otherwise stated. So anthropological evidence suggests that humans have been consuming meats for thousands of years. Originally, this was through individual hunting, where the humans personally witnessed the path from live animal to meat product. Today, as we know, though, we typically obtain meats through third-party sources, thus necessitating their regulation to ensure safety for consumers. The Wholesome Meat Act of 1967 strengthened consumer protection by giving the USDA regulating authority. The USDA's Food Safety and Inspection Service, or the FSIS, is the department that is responsible for providing the proper inspections of meat and to ensure that it is safe, wholesome, and properly labeled. The FSIS inspection personnel verify the humane handling of animals, ensure that the animals are free from disease and fit for slaughter, oversee the entire slaughtering process, inspect the carcass post-slaughter to ensure that it's fit for human food, and then they also confirm adequate cleanliness of the facility and the animals throughout the entire process. It should be noted that if a meat product is produced and sold only within one state, that the facility where it's manufactured is regulated by a state meat and poultry inspection program that has requirements that are at least equal to those imposed under the federal act. Additionally, an individual can slaughter and prepare meat on his or her own if consumption of that meat product is consumed, or if that meat product is consumed without any financial compensation. So as we know, overall meat production and consumption across the globe has drastically increased in recent years, and it's predicted to only continue to increase. From 1990 to 2009, aggregate meat consumption rose by almost 60%. Currently, an individual's average daily consumption of meat is estimated to be at 122 grams, with a third coming from pork and poultry, and a fifth coming from beef. The FAO predicts that by 2050, consumption of poultry, beef, and pork will increase by 100, 69, and 42% respectively. Researchers suggest that the driving forces behind this increase include population growth, increasing average individual incomes, as well as growing urbanization. And then it suggested that people who do choose to consume meat do so for its pleasing taste and desirable flavor, its nutritional benefits, and its association with social status, and its commonplace at celebrations and communal gatherings. All right, so we're gonna start going into the benefits of meat consumption in early childhood, starting with protein. Protein is a macronutrient that provides the necessary amino acids for physical growth and development throughout life. Additionally, proteins are used in the body to produce important enzymes, hormones, and other regulators, transport proteins, and immune system components. In order to support this development, children specifically need to have greater protein synthesis compared to protein breakdown, which is otherwise described as a positive net protein balance. The current recommendations of protein intake for infants age 7 to 12 months is 11 grams per day. Children age 1 to 3 years is 13 grams per day. And then children age 4 to 8 is 19 grams per day. Meat contains a large amount of proteins, and it's considered to be a high quality or complete protein, meaning that it provides all 9 essential amino acids. Also, the protein that's found in meat has a high biological value, which measures the ability of a protein to be used to synthesize other proteins within the body. Fresh cooked meat is made up of approximately 20% of protein, yielding rich amounts per serving of consumption. And in general, a 1 ounce portion size of meat yields about 7 grams of protein. When comparing different types of meat regarding their protein content, poultry is highest, followed by beef, and then pork. Many studies have found a positive correlation between protein intake during early childhood and growth. A study done by Tang et al. Aimed to understand how meat as a complementary food would affect a cohort of rural Chinese infants' anthropometric measurements over a 12-month span. Within the study, nearly 1,500 6-month-old infants were randomly assigned to either a meat group or a multiple micronutrient fortified cereal group. After follow-up measurements were gathered, the authors determined that in conjunction with meat being a great source for iron and zinc, meat-based complementary feeding increased linear growth more than cereal complementary feeding did. The meat group also had a smaller decline in length for age Z-score. So this means that whenever comparing the measurement data to standardized data as established by the World Health Organization, the meat group's LAZ scores were much closer to normal. The authors conclude that meat as a complementary food source may be beneficial for infants who are struggling to meet regular growth standards. So a separate study that was conducted by the same researchers aimed to compare how protein from meat as opposed to dairy-based complementary feeding affected infant growth and weight trajectories. So 64 formula-fed infants in the Denver, Colorado area were randomly assigned to consume either meat or dairy as a primary complementary food from the age of 5 months to 12 months of age. So formula and cereals, fruits and vegetables were consumed ad libitum, but protein was the controlled nutrient. The measurements were obtained, including length, weight, and head circumference. These were obtained monthly. The results concluded that LAZ increased in the meat group and decreased in the dairy group. And additionally, weight for length Z-score significantly increased in the dairy group as opposed to the meat group. And then in a follow-up study that was done by the same researchers, they looked at the same kids at 24 months of age, and they found that LAZ scores remained significantly higher in the meat group compared to the dairy group, which suggests a long-term effect. Like protein, fat is a macronutrient that's necessary for proper growth and development. Fats serve as the main energy source for infants, and then in excess, they're stored in adipocytes for later use. Fat intake is needed for the absorption of fat-soluble vitamins such as A, D, E, and K. They provide the essential fatty acids and cholesterol that's needed for the body to synthesize cell membranes and other hormones and mediators. And then in children specifically, fats are needed for the proper neurological function and brain development. So, therefore, fat should not be restricted at all for children that are under the age of 1. Whenever children reach the age of 1 to 3, fat should make up about 30 to 40% of their daily total caloric intake. And then at 4 to 8, this drops a little bit to 25 to 35%. It's recommended that fats that are offered to young children are mostly mono and polyunsaturated fatty acids that, as we know, are high in fish and nuts and vegetable oils. Meats can differ in their fat content based on their animal source, the age of the animal, the part of the animal that the meat comes from, and the animal feeding style. So the most common fats that are found in meats are monounsaturated fats as well as saturated fatty acids. However, meats do also contain notable amounts of polyunsaturated fatty acids as well, and trans fats can also be a component of meat products. Additionally, meat and meat products contain relatively high levels of cholesterol. So a 2009 review done by McAfee et al. Examined the benefits and the risks of red meat consumption, specifically concerning fatty acid intake in regard to human health. In this review, the researchers state that the lean tissue of red meat contains ALA, EPA, DPA, and DHA. And then as we know, these omega-3 fatty acids are known for their positive effect on heart health, central nervous development and maintenance, as well as inflammatory responses. Although the content of meat, although the amounts of these omega-3s are much lower in red meat compared to like oily fish, the author suggests that meat may have more of a significant impact on human health, as consumption of red meats is very high in Western diets. In support of this, many studies have shown that consumers of red meat have higher serum concentrations of omega-3 PUFAs compared to non-meat eaters. So similarly, a review done by Maragoni et al. Examined the fatty acid content in poultry in relation to health. They concluded that nutritional composition of poultry fat is favorable due to its significant amount of MUFAs and PUFAs compared to beef and pork. In addition, the researchers point out that the skin of poultry can be high in omega-6 linolenic acids and arachidonic acids, and that due to feeds that are high in ALA, poultry can be a good source of omega-3 fatty acids as well. Again, the authors of this review point out that because consumption of fish that are high in omega-3s is typically low in Western diets, poultry can be an important source of those beneficial compounds.
Now, moving on to more micronutrients in relation to meat consumption, we're going to first talk about iron, which is debatably the most important nutrient for children. So we know, as we've learned from many presentations before, that the maternal placental iron transfer stores deplete roughly around 4 to 6 months of age, and they deplete quickly after that. So it is very important that during complementary feeding times, the infants receive the proper amounts of iron. Their primary function is to carry oxygen to the body's organs and muscles and tissues. So we know that oxygen is crucial for energy development. And so without iron or proper amounts, then energy will be greatly depleted. We can see symptoms of lack of iron expressed through stunted growth, pale skin, mood dysfunction, lethargy, and we can even see it develop into anemia, as well as improper learning ability, delayed motor function, and inability to focus. We see that children's iron needs before 7 months rely heavily on those iron stores because the breast milk does not have much, and so we don't have to worry too much. And then after that, around 7 to 12 months, you can see that these numbers are switched. So 7 to 12 months, you need about 7 milligrams per day. And then 1 to 3 years, you need about 11 milligrams per day. In meat specifically, iron is in its heme form, which is just more bioavailable than the non-heme form of iron. So we can see that heme iron doesn't have to go through as much change when entering the enterocyte, just because of the pathway that it takes. So we know that heme iron is more bioavailable, more readily available. So when consuming meat products and animal products with heme iron, we're getting a little bit more than if we are consuming their non-meat counterparts. Foods specifically high in iron include beef, pork, chicken, turkey, and lamb, etc. Moving on to a study specifically looking at meat consumption in relation to iron and protein concentration by Engelman et al. They conducted this blind parallel randomized control trial in which they had two specific groups. They had a LMG, which is a low meat group, and an HMG, which is a high meat group. Basically, what they did was they took another observational study and they determined the geographical regular diet for this area, and then they applied the diet to each of these groups, and then just multiplied the high meat groups meat consumption by 3. They made sure that protein and iron consumption was relatively similar across the groups so that there wasn't too much discrepancy between their tested values. And then they looked to determine how hemoglobin concentration, serum ferritin, and then serum transferrin receptors was affected. They saw that the LMG had decreased hemoglobin concentration, but there was no differences in serum ferritin, serum transferrin receptors, or growth or learning ability. So, despite the hemoglobin difference, they didn't really see any other differences, and they determined that as long as the infant is consuming the correct amounts of iron and protein, then each source is sufficient. Now, moving to another micronutrient, zinc. Zinc is crucial for development in the early stages of life as it acts as a catalyst for normal enzyme function, immune promotion, protein and DNA synthesis, and cell division. Specifically, the National Institute of Health states that for regular growth between birth and 5 months of age, even in utero development, uh, it relies emphatically on zinc consumption. So we know that zinc is another extremely crucial micronutrient. Deficiencies can manifest through growth retardation, decrease in appetite, inability to hold down food, defective immune systems, diarrhea, delayed healing, weight loss, hypogonadism, and then delayed sexual maturation. And we can see the zinc requirements for infants below. In meat specifically, it's predominantly seen in beef, chicken, turkey, and pork. So those main meat sources that many American diets are founded on. Zinc is similarly found in meat that non-heme iron is found in meat. So it's in very high concentrations and is more bioavailable. But this bioavailability is not due necessarily to the fact that it's going to be more easily absorbed, but that it doesn't have any antagonists competing for absorption. So your other sources of zinc, like whole grains and nuts or beans, legumes, they contain phytates. And so these phytates will compete for absorption, so zinc won't be as easily absorbed. Moving on to a study by Daniels et al. They wanted to determine if there were any modifiable predictors of serum zinc concentration in 1-year-old children through this cross-sectional analysis. And they also wanted to determine if there was any relationship between zinc and growth indicators. So what they did was they utilized data on 115 toddlers from this other study, called this baby-led introduction to solids randomized control trial. And the data included diet records for 3 non-consecutive days, assessing dietary intake, as well as plasma zinc levels. So the study was trying to find a strong predictor of plasma zinc concentration for infants, as dietary intakes were only set to adequate levels and not sufficient levels. So basically, they found that red meat along with zinc fortified formula were very strong predictors of plasma zinc concentration. So they determined that plasma zinc concentration was something that was easily measured, and the high consumption resulted in high concentrations. So that's a positive. But they also determined that food fussiness was kind of related to zinc concentration. So the lower the concentration of zinc, the more fussy the infant was with food, and vice versa. And then there was no association between serum zinc and growth indicators. So that just means that there is not a tested or measured worry between serum zinc levels, but I don't think that the study was fully encompassing in what they were testing. So I think that just determining if zinc was a measurable micronutrient, then it was sufficient. Moving on to selenium. Selenium is just a cofactor enzyme regulation, and basically it acts to oxidize the modification of many different macronutrients such as lipids and as well as glucose and protein. They control inflammation, immune response, thyroid and metabolic function, as well as DNA repair. The primary role of selenium is seen as selenomethionine, which is just used for DNA repair. And we know that stores of selenium are seen at 26 to 48% in muscle. So basically, this just means that it's seen similarly in animal products. So the animal flesh of beef, chicken, and pork all have high amounts of selenium. And you can see the childhood needs below. In meat, it's kind of niche what has the highest concentrations of selenium. So we see the top three are yellowfin tuna, sardines, and canned shrimp. And while these sources are kind of not eaten as frequently in the American diet, we see other sufficient sources such as beef, chicken, turkey, and ham. And especially because the American diet focuses so heavily on meat products, there's not really a deficiency worry with this. Fun fact though, Brazil nuts contain the highest amount of selenium, toppling every other percentage selenium concentration by a lot. So Brazil nuts are the best source of selenium. Moving on to a study looking to understand the association between selenium and cognitive function. It had been previously understood that selenium concentrations had a positive association with cognitive ability in older adults. So they wanted to determine if this association transferred to infants and toddlers as well. So in this longitudinal study, Schroeder looked at 1,408 Bangladeshi children, assessing cognitive ability once they reached the ages of 5 and 10 years old. And so they followed these infants from being inside their mom to birth to 5 years of age and 10 years of age. And they even measured maternal plasma concentrations as well as hair and urine of the children. And then they just assessed using an intelligence scale that they provided. And they did determine that there was a strong association between selenium and childhood cognitive function. So we can understand the emphasis of its importance and possibly why meat could be recommended in children who are at risk of low selenium diets. Moving on to another micronutrient is vitamin B12. So as Lainey stated, vitamin B12 could be a worry for vegan and vegetarian diets, but primarily vegan diets. And it's extremely crucial in many, many different processes. We know it as a function in a methyl donor nutrient cycle, typically used to repair DNA, RNA, and create various hormones, proteins, and lipids, as well as red blood cell formation, nerve function and activity, and then a cofactor to produce methionine as its, in my opinion, most important role. Deficiency symptoms can manifest in many, many different ways through megaloblastic anemia, failure to thrive, movement disorders, developmental delays, and then a lot of cognitive disabilities like confusion, loss of memory, and depression, along with fatigue, tingling in the extremities, and loss of appetite. And then you can see the childhood needs below. In meat, it's basically found ubiquitously throughout animal products. So you can see it in beef, pork, poultry, and as well as eggs and dairy product. So it's really those vegan diets that are the biggest worry for not obtaining the correct amounts. And we can also see that the absorption is relatively debated in how bioavailable it is. It's about 50% bioavailable, just kind of depending on the person's specific intrinsic factor release in their stomach. But we also know that the more B12 you consume, the less bioavailable it will be because your body has an intrinsic factor like threshold, so it can only release so much. And then there's only a few non-animal based sources, but they're going to be fortified, so they won't contain naturally occurring amounts. So that'll be nutritional yeasts and cereals, and then those are even less bioavailable. Now moving to a study, we're looking at Strand et al. Wanted to understand how 500 Nepali mother and infant pairs assessed maternal B12 stores in relation to linear growth up to 5 years of age. So B12 was thought to have an implication on growths in early childhood, and so they looked to test this theory basically. They displayed that these maternal B12 stores actually did have a strong dose dependent response association with linear growth, and the researchers tried to control for as many confounding variables as possible. So we do not know if the ones with worsened growth were just stunted temporarily or had permanent growth hindrance. So while this study does elucidate the importance of having B12 for growth, I don't think it shows that the stunting is permanent or not. So it would be interesting to see a little bit longer of a study after this. Moving to a few less important micronutrients, we'll start with phosphorus. It just plays a large role in human bones, the phospholipid bilayer of cell membranes, and is in part of the most important energy contributing nutrient in the body, ATP. So we see recommendations below, and if a child is not meeting those recommendations, then deficiency is considered hypophosphatemia, which can just be exhibited through anorexia, anemia, rickets, since it plays that really strong role in human bones, osteomalacia, ataxia, and then increased risks for infection. I think it's because the pathogens are more able to penetrate the cell layers because that phospholipid bilayer isn't as strongly intact. And they can be found universally in meats, seafoods, eggs, dairy, and then many, many non-meat products like legumes, grains, and various vegetables. And while phosphorus is extremely important for infants, for energy metabolism, and in consumption, breast milk will provide optimal amounts up to 1 year of age. So many sources outside of meat aren't, even meat sources aren't necessary for phosphorus specifically. For vitamin B6, it functions to aid in amino acid metabolism, acting as a coenzyme, developing neurotransmitters, assisting in homeostatic functioning of lipid, glucose, and protein metabolism, along with hemoglobin formation and immune function. So this is another one of those nutrients that infants don't necessarily need to consume, but it's so high in meat and so important that if meat is consumed, then the worry for deficiency is basically evaporated. But deficiency can be seen through sensitive mood, irritability, impaired hearing and seizures, and then depression, confusion, microcytic anemia, and immune system dysfunction. This one's kind of tougher to measure deficiency risk for just because a lot of the symptoms, besides microcytic anemia, can be related to other nutrient deficiencies. So it can sometimes be tough to understand this specific deficiency. And then the richest sources are just your organ meats, salmon, chicken, beef, and turkey. So meats do have the highest sources. And moving on to our last micronutrient of importance is niacin. Niacin functions as the primary electron donor in hundreds of enzymatic processes. We know it as NAD, which is just the most abundantly vitamin-derived used enzyme in the human body, accounting for more than 400 different enzymatic processes, and we can't create ATP without it. And so we know that this and phosphorus almost work in conjunction for energy metabolism. And then you can see recommendations below, and you can see how it grows relatively linearly through the years. Deficiency is called pellagra, and it occurs through skin rashes, bright red tongue, GI discomfort, fatigue, loss of memory, and other extreme neurological abnormalities. Like the previously two mentioned micronutrients, this is another one that you don't need meat to intake, but meat will aid exponentially in the consumption of this nutrient.
All right, so we're gonna switch now to talk a little bit about the concerns with meat consumption in early childhood. Um, Although adequate protein intake is vital to sustain proper development and growth of infants and young children, protein intake that exceeds recommendations is associated with adverse health outcomes, notably the increased risk of obesity. So this early protein hypothesis might explain this association. It's hypothesized that excess protein intake stimulates the growth hormone insulin-like factor 1 axis, driving early differentiation and proliferation of adipocytes, leading to weight gain, and then thus increasing a child's risk of obesity. This idea relating high infant protein intake to weight gain has been widely demonstrated in various studies with the high protein content in infant formulas, but obviously since our presentation is over meats, we're going to focus on complementary feeding. So in a large prospective cohort study of twins, Pimpin et al. Investigated whether high protein intake as a proportion of total protein intake post-weaning was associated with increased weight gain, BMI, and overweight or obesity risk in children up to 5 years of age. To assess this, weight and height measurements of the twins were obtained every 3 months and then until they reached the age of 5. And then at age 3 and 5, BMI was calculated and then classified as underweight, normal weight, overweight, or obese. Dietary intake was obtained using a 3-day dietary recall diary that was recorded by parents. And then results concluded that greater protein intake relative to total protein intake was associated with higher BMI and weight, but not increased height. Furthermore, protein intake was significantly associated with overweight or obesity risk at 3 years of age, and then showed a trend for increasing this risk, though not statistically significant, at 5 years of age. So results from a study conducted by our very own Dr. Chrishell supported this association between protein intake in early childhood and risk for obesity. So in this study, the researchers aimed to compare the diet quality of children aged 2 to 5 that were attending a child care center in Hays County in order to inform a obesity-related center-based intervention, because children in Hays County have an extremely high risk of being overweight or obese. So dietary intake was recorded using a 24-hour recall that was completed by parents, and then diet quality was assessed using the Healthy Eating Index. The researchers found that children within the regional sample consumed higher protein intake relative to their total energy intake when compared to the national sample from NHANES of 2011 to 2014. Furthermore, the authors suggest that this high protein intake, or they hypothesize that the high protein intake of these children may be contributing to the high rates of overweight and obesity within the community. So, as we know, as nutrition students and professionals, dietary fat is beneficial to health in moderate quantities, but can definitely have detrimental health outcomes when consumed in large quantities, especially if the consumed fat is mostly of trans and saturated fatty acids. So high intakes of these specific types of fatty acids, as well as high intake of total fat, is associated with increased risk of developing cardiovascular disease, including coronary heart disease, stroke, and myocardial infarction, as well as certain types of cancers. So the aforementioned McAfee review stated that the 3 main saturated fatty acids that are found in beef are all positively associated with an increased risk of CHD. And the authors also conclude that high consumers of meat had increased intake of cholesterol, as well as increased plasma concentration of total cholesterol, LDL cholesterol, and triglycerides. And of note, we know that LDL cholesterol can contribute to the development of atherosclerotic plaques, and thus can contribute to the development of CVD. Meat consumption has also been associated with increased risk of cancers, and fat and high fat intake has been associated with this as well. So particularly cancers of the breast, colon, and rectum. So researchers believe that the two might go hand in hand. This association could be due to a couple of variables. First, a diet that's high in fat or meat is likely to be lacking in whole grains, fruits, and vegetables, all of which have a protective effect against cancers. And then secondly, diets that are high in fat or meat are associated with increased obesity, which we know that is also in itself a risk factor for developing cancers. So when relating this to fat intake during childhood, as previously mentioned, fat intake should not be limited for children under 1 year of age. Additionally, it's also postulated that fat intake during childhood, even if it is in amounts that's above recommendations, is generally considered safe for the child. But high childhood fat intake can still have other health implications. So in a review that assessed dietary fat, adult diseases, and childhood nutrition, the author Law emphasized that although high serum cholesterol can be reversed with improved diet, a longer duration of high fat intake can substantially increase one's risk of CVD. Law also relates this same principle to the development of cancers in adult life, stating that a longer duration of unhealthy dietary patterns that may promote cancer development can increase one's risk of developing cancer later in life.
Moving to a couple of additives that we see or typically talked about relatively volatilely in meat is hormones. So hormones have been used a lot more, especially since the industrialization of farming has happened. Hormones are used to increase the size of the animals so that flesh just yields greater amounts, making more money for the farmer. And multiple studies have analyzed hormone content in different meat products, specifically like chicken, beef, and pork, as we see in Lopez Garcia's et al. Study. They looked at 31 different meat samples, uh, basically evenly across chicken, beef, and pork. And they only found one beef and one pork sample that contained hormone values above the determined USDA limits. Specifically, they found progesterone as the hormone in beef and hydrocortisone in pork. And while it was interesting that these studies only found 2 examples of the 31 that did have hormone concentrations of note, they basically concluded that because of the different cuts of meats, how they're raised, how much of the hormone is injected, where you buy the meat, how long the meat is served, if it's frozen, there's so many different attributes that can contribute to this. The results were inconclusive for the most part. Another study by Kolick et al. Looked to review the endogenous hormone use in the beef industry. And they just found that the product that had the higher fat content typically had higher concentration of these steroid hormones, since we know that these hormones are fat soluble. So for example, we see higher concentrations in fattier cuts of beef compared to leaner cuts, and then the highest concentration undoubtedly was in whole milk. And so while it doesn't really explain how dangerous or how potent these hormones can be for humans when consumed, it just heeds warning for any consumer. And if someone should be worried about hormone consumption for their infant or for themselves, to just avoid this meat consumption altogether. Moving to another additive that is highly debated, antibiotics. So antibiotics are another product that have been used more heavily as industrialization has occurred. The high populations of farm animals in small spaces and the tight, low amount of space that each of them have contributes rapidly to the generation of pathogens and diseases. So the use of these antibiotics became almost necessary, but there's a evil that comes with the high use of antibiotics, and it's the antibiotic resistant pathogens. So as they're used more heavily, only some pathogens will survive, creating these antibiotic resistant pathogens. So while there's not a specific mechanism elucidated transmitting antibiotics from livestock to tissue to plate, there still is that concern that they could have effect on humans since it hasn't been fully laid out, but the biggest concern are the creation of pathogens. Moving on to preservation methods and curing. So curing is just the primary method in which meat is preserved, and it's done so through the addition of lots and lots of sodium nitrates, which are basically just chemicals used to preserve. They draw the water out and they make sure that the meat can be stored for longer periods of time. But the problem is that there's over 200 different N-nitroso compounds, and all of them are seen to be carcinogenic. So any sort of preservation or curing that is done to meat typically will add to the carcinogenic risk. Specifically, Sarasua and Savitz found that one hot dog or one hamburger per week or more is associated, consumption by a mother is associated with the development of childhood brain tumor development. And while they didn't specifically cite where the hamburgers were from, where the hot dogs were from, the fact that there was even an association there after they controlled for variables using multiple regression, it's kind of a worry. And it's almost as if curing and preservation of these highly processed meats should just be avoided completely. Another study by Dietrich et al. Assessed how these N-nitroso compound exposures during pregnancy and early life affected tumor incidence, and they found extremely varying results. So we saw that a couple of the studies had a significant association with these N-nitroso compounds and tumor development. A couple of the studies had negative associations, and then one of them found an association without significant results. So, blanket recommendation, avoid these compounds altogether, especially for infants and children. Now we're going to look to different cooking methods. So cooking methods are just applying heat to the meat in order for it to be safe for consumption. And typically it's going to affect the meat's structure, the texture, the palatability and the flavor, the water and fat content, and as well as the protein structure. We know that it'll affect proteins at the secondary, tertiary, and quaternary level, but not the primary. But there are some cooking methods that are dangerous. So, for example, barbecuing, grilling, smoking, and frying of meats all have displayed the creation of mutagenic oxygen species, which are called polycyclic aromatic hydrocarbons, or PAHs. So these compounds can greatly affect the risk for developing cancers, and they do so by affecting cell proliferation through the manipulation of DNA replication, mutation, and tumor genesis. And then PAH are specifically associated with stomach, lung, and other respiratory cancers. So infant consumption with these cooked methods is completely suggested to be avoided.
Okay, so as all of us know, again, as nutrition professionals, that nutrition and dietary patterns significantly influence an individual's status of health throughout all stages of life. Specifically, the diet in early childhood has the potential to program future health outcomes of an individual. The first 5 years of life is the period in which these early feeding habits are established based on parent and caregiver modeling, familial beliefs, and the cultural environment. So, for example, flavor and taste preferences, timing and frequency of food intake, and acceptance of new foods, as well as self sustaining food customs, are heavily ingrained into the infants and toddlers by watching and mimicking their caregivers. Therefore, it's important to establish healthful early feeding habits that can effectively serve as a foundation for future dietary practices that are equally as healthful. So in a review analyzing the various psychological aspects of meat consumption, Madlinska et al. Discussed the difficulty of altering one's food preferences and eating habits. The researchers introduced this notion of the 3 N's of justification for why individuals choose to consume meat. Consuming meat is natural, normal, and necessary. In other words, it's a part of human evolution, so it's natural. It's common in cultures across the world, so it's normal, and it provides essential nutrients for ensuring good health, so it's necessary. Additionally, sometimes a 4th N is present in justification that consuming meats is nice, meaning that it just provides pleasure through taste and satiety. So Individuals who use these ends of justification are generally less likely to ever give up eating meat. Furthermore, habitual practices and emotional attachments are major factors that influence meat consumption, where those who eat meat as a routine part of their daily life and who are strongly attached to this meat consumption are less likely to ever reduce their meat intake. So this presents a problem when considering aspects of a healthy diet, in which the logic is pretty simple. Higher intakes of meat leaves less room for adequate intake of fruits and vegetables and whole grains. The World Health Organization describes a healthy diet as including fruit, vegetables, legumes, nuts, and whole grains, less than 30% of total fat intake from sugars, less than 30% of total energy intake, from sugars and fats, with less than 10% from saturated fats, and then less than 5 grams of salt per day. With respect to infants and children, this healthy diet is similar to adults, but should also include breastfeeding, according to the World Health Organization. Furthermore, the World Health Organization, as you can see, makes no mention of consuming meat for a healthy diet. The CDC also estimates that only 1 in 10 American adults receive adequate amounts of fruits and vegetables. So this underlines the potential negative implications of establishing meat as a large and significant part of the diet early on in life. And then lastly, we're going to look to vegetarian diets, specifically benefits and concerns within early childhood. A review that was done by Van Winkle et al. Looked to understand the benefits and the drawbacks of children consuming a vegetarian diet. More specifically, the authors wanted to determine if consuming a lacto-ovo-vegetarian diet or a vegan diet affected infant and child growth, development, and dietary and nutrient profiles. Citing 9 different studies, they concluded that there was no disruption to growth and development related to weight and height in children and adolescents who consumed vegetarian diets. Vegan diets, however, reported children who were smaller and leaner than their counterparts. Furthermore, iron and zinc consumption, while it was decreased in the vegetarian and vegan diets, they didn't display any negative effects when it was compared to omnivorous diets. The greatest discrepancy between the two diets was vitamin B12, as we know, because vegan diets have no direct source of this nutrient. The final conclusions of this review stated that meat consumption for infants and toddlers is not required by any means, especially if other animal products are consumed in conjunction, like dairy and eggs. Furthermore, studies indicate that perhaps plant-based diets can be an effective approach to for the prevention of childhood obesity. However, it should be noted that vegan, especially, and vegetarian diets in early childhood should be well planned and include nutrients that are aligned with the child's dietary recommendations. So to address this well-planned necessity of childhood vegetarian diets, Baroni et al. Created this Veg Plate Junior, which is a planning guide for vegetarian diets in infancy, childhood, and adolescence. The VPJ centers on 6 food groups: grains, protein-rich foods, fruits, vegetables, nuts, and seeds, and fats. Furthermore, to be adapted for infants, a 7th food group is also present, which is just breast milk. The VPJ emphasizes omega-3 and calcium-rich foods and highlights the importance of foods that are reliable sources for vitamin B12 and vitamin D. It is recommended that if dietary intake can't meet these recommendations for those nutrients, that supplementation should occur. So the authors contend that healthcare professionals, as well as parents and caregivers, should utilize the VPJ to achieve optimal dietary patterns and nutrient intake for vegetarian children.
All right, so moving quickly to recommendations, we're going to provide different requirements for healthcare professionals and parents based on the research that we've conducted. So first, for healthcare and nutrition professionals, we recommend a well-rounded diet just to ensure the consumption of a variety of different colors, food types, whole grains types, fruits, vegetables, and all the great things, as well as fats and dairy products. With protein, we encourage adequate protein intake. but inform parents of the risks associated with overconsumption, as Lainey discussed. With fat intake, we know that up to about a year, fat intake is accepted and isn't regulated too heavily for infants, but emphasizing mono and polyunsaturated fatty acids is important, and adequate intake is appropriate after 1 year age. Looking toward micronutrients, it's important to note the specific ones that we talked about today, for example, iron, zinc, selenium, phosphorus, vitamin B12 and B6, and niacin, B-MET. And then consuming meat versus vegetarian diets, it's recommended that meats can be consumed to help meet the requirements for these nutrients that we listed, such as the fats, the proteins, and all the micronutrients. But health professionals must be very respectful of cultural differences and wishes for the families to not consume meat product. So we know that the professionals should be educated and understand how to prescribe diets for these specific infants and children who are not consuming meats and possible animal products as a whole. Looking to some of the additives and cooking methods, hormones and antibiotics, uh, healthcare professionals just need to be informed on the possible dangers and understand the current research, as research hasn't fully elucidated the mechanism to which these chemicals work to affect meat or the infant consuming the meat. It's just best that they understand the possible concerns and teach it properly and educate their patients properly. Processed meats should be encouraged to be completely avoided for mothers and children's, specifically cured meat products. Looking towards parent-specific recommendations, we should provide foods that meet but do not exceed protein requirements, as well as not restricting those fats for that first year of life, but providing a high amount of the healthy fats, as Lainey was discussing, mono and polyunsaturated fatty acids, and then limit those unhealthy fats, saturated and trans fats. Providing foods that can meet the micronutrient needs, whether it is meats meeting sufficient needs for those micronutrients discussed or other products. And then if an omnivore diet is preferred, meat should be fully cooked to the appropriate temperature using the appropriate cooking method, be served at the appropriate size and consistency for the age of the child. And then if a vegetarian diet is preferred, it should be well planned and should take care to the specific nutrients that could be deficient, such as protein, zinc, iron, B12, the ones we discussed, and to recruit help from a nutrition professional to plan a safe and healthful vegetarian diet. Now, to provide a conclusion summary with some future research, we look at the consumption of meat evolving rapidly as availability becomes close to ubiquitous. The nutritional value of meat makes a great argument for its intake and emphasizes how important it can be, but it is not necessary for infants and young children, as long as these parents are very careful with those specific nutrients, such as protein, iron, B12, zinc, and selenium. We know that meat is a great source of a variety of those macro and micronutrients, and some health concerns should be noted with overconsumption of meats related to saturated fat and protein, as well as the effect of infant taste and the acceptability of other foods later in life. Other considerations when consuming meat include hormone and antibiotic concentration, along with preservation, cooking methods used, and healthful diets later in life. Future research would be compulsory to include more observational longitudinal studies. So for instance, looking at how the consumption of meats early in life affect late life growth development, such as 5, 10, 15, 20 years down the road, along with additional randomized control trials comparing the differences between growth and development when consuming meat proteins and fats compared to plant-based proteins and fats. All right, that's everything. Y'all have any questions?
I have a question. I think that you might have mentioned this before, but what is technically like a high amount of protein or too much? What is too much?
Yeah, so we listed the recommendations. I think it was 11 grams per day for let me go back to it.
Is that just a general recommendation, or are those given in relation to their kilograms?
That's just a general recommendation. Yeah.
Okay.
Yeah.
Okay, thanks.
Sorry, did you want me? It was 11 grams for children. Let me pull it up.
I think it was 7 to 12 months.
And then it went up to, I think, okay, let's see, I got it.
Okay, if it's in the PowerPoint, I was just curious.
Yeah, so it was 11 grams, then 1 to 3 years was 13, and then 4 to 8 years was 19 grams. You can also find information, I didn't want to like, because you can find it in per kilogram of body weight. You can also find it for percentage of total protein intake. I mean, energy intake, yeah.
Okay, thanks.
So what's, in terms of ranking, what do you think is the worst thing about meat for respect to kids? Like if you had to pick maybe one of the top 1 or 2 concerns that you would tell your family member right now that's getting ready to feed a kid.
Go ahead, Jake.
Okay. So I was going to kind of piggyback on what Lainey was talking about earlier or later in the presentation on how too much meat consumption could almost take away from the consumption of other nutrients. So like high amounts of meat can take away from your fruits, vegetables, and whole grains. And it also affects the palatability of foods later in life. So we know that the introduction of many, many different foods is so important, and having a variety of these foods and introduction multiple times in the lifespan of an infant is so crucial. And meats being a dominant consumption or a dominant dietary property just kind of sets the child up for failure later in life because they don't have that acquired taste for other foods, despite the great nutrient profile that meat has.
I was gonna say a similar answer, but I might be biased because I am a vegetarian, but like establishing those eating patterns, because it's so easy to get convinced with other things with just like how the Western diet is. So like implementing healthy eating patterns that might contradict what the child sees in just like everyday life would be really important.
What about just foregoing beef? How much would that help? Like if you've said, eat fish and chicken, but maybe beef is a little too much. Would that make sense to you guys or no?
Definitely. I would say yes. I would say if meat is going to be consumed, that it should be like the leaner types of meat, like chicken and poultry, but mainly focus on seafood, the fish that has high omega-3s.
Yeah, and you guys didn't need to put this in there, but it's been talked about in other presentations, is the environment. Our dependence on growing beef is ruining the planet. So you got to weigh, do they want to live to be 80 or not funny, but real.
Yeah.
Ruining the planet. And I think y'all made the point that it's expected to grow by 100%, or its consumption is increased by 100% in the near future. So doubling. So that's awesome.
Yeah. And then also like the use, in addition to like the impacts on the environment, the use of resources that goes towards raising beef, like the water, and as well as grains, like a ton of our grains that are produced go towards just feeding the beef, which in terms of like its effect on world hunger, I guess would be how we allocate resources.
And of course, you brought this up, but the lifelong habit of being a big meat eater is not good, right? It doesn't. We don't find positive correlations really with high meat intake and health.
I had a question. You'll have to excuse this, maybe kind of a novice type question, but early in the presentation, I believe one of the studies showed that meat consumption amongst a high meat group compared to like a low meat group was correlated with increased linear growth in the child. I believe it was.
Yes.
Is that bad? Is that
no?
So of that.
So I'm pretty sure that that just means that, or it does mean that the growth is normal. So we see like that regular growth. So whenever you look at like childhood growth like scales and you like can see the percentiles, they grow in a way that is relatively normal. And I believe that it was across both groups that they saw relatively more normal growth. So it didn't really matter too much if the protein and iron source was coming from non-meat based sources or meat based sources.
Got it. Yeah, because when you see bad, it's like, oh, they were an excessive weight for length, right?
Hmm.
Right.
So
So
yeah,
those are they if it found it was generally considered good for the child to have linear growth because you don't want growth stunting at all. But whenever it was weight growth, especially for compared to age or length, that was considered unfavorable.
awesome. Thanks.
Thank you, Lainey. You explained it well.
Okay, well, let's start the discussion.
All right, you guys see the PowerPoint full screen? Yes, okay. Perfect. Well, me and Xavier today are going to be covering the omnivore versus vegetarian diet and kind of looking at what is healthy. So in our culture, it's common for the diets that are deemed healthy to be extreme. Some people can hear that keto is healthy or being vegan is healthy. But ultimately, these are complete opposites, and that can really confuse consumers. Actually, I was at Target yesterday and I took a picture of this keto thing myself. I didn't take that from the internet. So people just walking the aisles are seeing like vegan is best, keto is best, and it can be really confusing. So I got an example from Joe Rogan podcast. For those of you who don't know, this is one of the biggest podcasts, and it gets over 1 million listens per podcast. And he interviews lots of people on trending topics, and meat consumption is a trending topic. So we don't have time to go over these YouTube videos because they are long, but I highly encourage watching these. So the first video is supportive of red meat. There are two weightlifters who have their science, and they basically state that the science that they've read is that vegetables are neutral and that red meat, all meat should be consumed. And then the second one is by Dr. Rhonda Patrick. And for anyone who knows her, she is big on social media, did a PhD in cell biology and did her postdoc in nutrition, and then is big online with all of that. And she kind of covered all the different perspectives, and it's pretty great. It's a great listen. But ultimately, whatever podcast they choose to listen to is what their perception is going to be, because the odds of someone listening to all the 7 different types of podcasts that he has on meat is going to be pretty low. So personally, I think that in our culture, unfortunately, this is my opinion, I think that these diets happen because they equate thin to health. And as we know, that is not true at all. And so we're gonna play a little game. So if you guys could take your phone out and Google Kahoot Play, and it should, the very first thing, it should say Kahoot Play, enter game pin here. And I'm gonna exit my stop share really fast. And my slideshow really fast. And then I'll put the pin here. So these are going to be just 7 questions, and you're going to have 30 seconds per question if my internet could work. Okay. Some of these are MNT type questions. Don't worry. Honestly, all of these could be a right answer. So if you don't get it right, whatever the case, you can probably vouch for your answer. So no big deal. My internet loves to shut down as soon as I need it to. Okay. So I'm going to turn this volume down. So the pin is up top. Okay. Are we all in? All right. I'm going to go ahead and press start. A child with chronic epilepsy is attempting a diet to help keep seizures under control. Which diet could be best? Awesome. So the keto diet is being currently studied for seizures. A child with PDCD, which is pyruvate dehydrogenase complex deficiency, which lacks the enzyme to break down carbohydrates, would need which diet? Awesome. So since they can't break down carbs, meat is their only other option. Well, not only, but it's hard. A patient with significant family history of heart disease could benefit from. It depends. It depends on the patient, but varied diet is great. High red meat. So the fat in red meat, saturated fat, isn't necessarily great for the heart, but if they're really obese, sometimes trying to put more fish and chicken in their diet can help them lose weight. And then vegetarians have healthy fats. So it just depends. A patient with a significant family history of colorectal cancer could benefit from. Yeah, looks like y'all all got it in one way or another. So as discussed in the presentation, red meat is correlated with some cancers. So either one. Which diet could potentially be more harmful to a diabetic if not well monitored? Awesome. So with a keto diet, you can go into diabetic ketoacidosis, and high carb can cause really high blood sugars. So varied diet is best. A patient with strong feelings about animal rights or welfare could possibly be more comfortable with. vegetarian diet. Yay. Okay. Ooh. Awesome. Let's see who won. Okay, well, I don't count. Lainey. Congratulations. Okay, so I'll go back to sharing the PowerPoint.
Okay,
Okay.
cool. So now following that game, we have some open-ended questions for you guys. So the first one is, are there any situations in which a high protein diet is beneficial, and what are they?
Yeah, so I mean, if a child has epilepsy and is medically needing to be on a keto diet, a high protein diet would be beneficial. I don't know, I haven't read whether if it would be beneficial to eliminate red meat from that diet, like or maybe provide education on protein, like high protein sources that would be most beneficial. Like potentially the exclusion of processed meats. I'm thinking like deli meats or like sausages, but the keto diet for a child who has epilepsy would be beneficial. I haven't looked into whether like certain meats can be excluded from that. I mean, I would assume processed meat could be. I don't know about red meat.
Yeah, I haven't read about that either, but that would be a really good read, actually.
What about
But yeah,
like,
we kind of covered some of these.
for wound healing, maybe?
Yeah.
I was just about to say, yeah, if you're working with someone who's in an extreme state of distress, so like high amounts of burns or broken bones or lots of torn flesh, not to be graphic, but need high amounts of protein in order to properly recover. And so I don't know if that would, like y'all were saying, I don't know if that would exclude or include red meat, but I'm pretty sure any source of protein is what's pushed in those situations.
Our our athletes too are going to need,
Absolutely.
given the sport, of course, they're going to need a higher protein content for recovery.
How much
I feel
higher?
like in general, if it's within the dietary guidelines for Americans, as far as the red meat question goes, then inclusion is acceptable.
There's a lot of athletes that get vegetarian vegan diets.
Mm-hmm.
Just throwing
Yeah.
it out there.
Yeah.
I feel like there's an emphasis on meat that's gone on way too long in the gyms. And people equating eating, muscle fiber to growing muscle fiber.
Mhm.
I'd be concerned about. I mean, you're right. And how much more protein do they need? Did y'all cover this in your last metabolism class?
Sports nutrition.
Sports nutrition. What was the upper limit on sports nutrition? You remember? I used to teach this, but it's been a while.
I think it was something like 2 point something grams per kilogram.
So it used to be about double. So it was 0.8 grams per kilogram. So it used to be like 1.6, doubling the RDA. So it's even up to 2 now. Okay. I did not know that. It seems high, but anyway.
I think that would be for more of an extreme sport, such as like powerlifting or maybe like a professional football player or something like that. But
Well, it can also be, I just did a presentation on proteins for sports nutrition, and of course now it's like but it's also beneficial for endurance athletes as well, because they utilize, or like their body utilizes branched chain amino acids in a way more so than like powerlifting or high intensity.
But is the meat, can you justify meat for that? I'm just curious.
I mean, just as long as you get complementary proteins without meat, like as long as you get those essential amino acids, then you should be good to go.
So higher protein need, not necessarily higher meat need or meat need at all.
My only argument with that is that I feel like you'd have to eat more to get enough protein if you're not using meat. So that's, I think, maybe one area where you would consider having meat, because I just feel like you would have to eat substantially more food to get the same amount of protein.
Well, with athletes, so they need carbohydrate intake as well for like optimal performance, and then also protein is protein is not, I don't know, not better absorbed, but like better utilized if you do also have protein carbohydrate intake. So foods other than meat have, like whole grains, they have protein and carbohydrates, so that can be beneficial.
Yeah, a lot of plant sources have both. That's a really good point.
I would also say that, damn near everybody eats too much. But I don't think it's usually coming from, we're eating too much whole grain or anything. I think my opinion is you can get the protein you need from your real foods diet with or without protein, but your excess calories, I would suggest, would be coming from those, marginalized treat foods,
Cool. So we just have 3 more questions. So the next one is, are there any situations in which a low meat protein diet is beneficial, and what are they?
Renal disease, when you're not on dialysis.
Right.
For sure.
If someone wants to not consume meat for ethical reasons or moral reasons.
Definitely. And we had covered these mostly in the game. We just wanted you guys to have a chance to say something that maybe y'all were thinking.
PKU, metabolic disorders.
Absolutely.
I know high red meat consumption is associated with colorectal cancer in older adult males, and so reducing meat consumption for that reason, not necessarily protein related, but meat specifically.
Absolutely.
Yeah, I agree with that, Jake.
Yep. Cool. And what type of diets do you feel are the most popular right now, and why do you feel they are popular?
Anything high protein.
Yeah. I feel like more so than diets, I would say words, like trendy, like terms, like clean eating and keto. Like a lot of people don't even know what the diet actually is, but they're like, oh, I'm going to try to go keto.
Yeah, or like gluten-free diets.
Yeah. Like I feel like trendy terms, I would say.
I guess I feel like protein is so high protein diets are so high because carbs are so demonized. And so, I just feel like I lost my train of thought, but I guess think popular, even like clean eating is associated with limited carbs or like no carbs, or I think people have this that don't know about gluten-free, like assume that, oh, because I'm eating a gluten-free Oreo, therefore it's an Oreo that has less carbs than a regular Oreo. It's just like this. And I'm like, what? Like just because you ate 2 chocolate chip cookies and they were gluten-free does not mean they're suddenly healthy for you. But there's this association that I think people make with clean eating means no or limited carbs and high protein, and there's just a very much a disconnect in the education that they're reading. So that's just something I've observed.
Even like a disconnect in like thinking high protein is always good, because high protein isn't always good. It can cause bone demineralization at 1.2. So
yeah,
people don't understand that everything needs balance very well.
Sure.
I think keto is very popular because it's like associated with like, I can still eat these foods that are deemed unhealthy and lose weight at the same time. So it's like convenience, like I can still eat this hamburger and then be good to go. Well, I guess hamburger has the buns, but yeah.
But yeah, it's like, oh my gosh, I can still eat bacon and butter with my pasta or like my zoodles, and I don't even realize I'm not eating carbs. And it's like, no, that's not it.
Bacon and butter were the first 2 that I thought of as soon as you said keto diet.
What everyone talks about. They're like, I'm on a diet, but I can still eat bacon, butter, and cheese. And I'm like, oh.
I love that y'all brought up the Joe Rogan podcast, because I feel like celebrity culture can really endorse and make a diet popular so easily. People will follow what they eat.
And what I thought was funny was that So Joe Rogan's job in that is to draw in as many listeners as he can in every way. So he brings in like all the perspectives. He has like 7 different podcasts about meat. So, and you know, if you've ever watched The Social Dilemma on Netflix, whatever Google reads you as and whatever they think that you want to hear is what's going to come up first. So he's just trying to get all of the answers and all of the perspectives, but that doesn't mean that everyone's going to hear all of them.
Yeah. And what he advertises as scientific research is not always just that.
Yeah. But I did really enjoy the Dr. Rhonda Patrick one. So if y'all have a drive or something.
She's awesome.
Yeah.
She's so awesome. Yeah.
He kept trying to like get her to say like one answer, you know, like, is it good? Should we be eating more? And she would always bring him back and put him in his place. And it was really nice.
I'll have to go listen to that. Thank you for providing that.
Yeah.
So we have one more question left, and it is, how does SES play a role in these 2 diets?
I feel like as with everything, what's often seen as healthy is also often seen as privileged.
That's true.
I think also kind of the opposite of that, I guess, would be like a lot of the times like a vegan diet is like people associate it with it being really expensive, and like fresh produce is a lot cheaper than buying a steak that costs $13 from the grocery and feeds one person.
True, but then there's the time factor of a lot of these people may have multiple jobs and they can't just buy fresh produce and have to chop it up, cook it, do stuff with it.
Definitely.
And it also plays a role there. Yeah. I feel like it's more accessible to people, especially if you're using food pantries or stuff like that. Think about like what you see there. You're seeing a lot of breads and like the bakery donated items and stuff like that is usually what they have the most of. So they're not really getting to get a good protein source from that, or solid, healthy meats and things like that, or even plant-based proteins aren't offered much at food pantries.
The thing that bothers me about this, though, is I agree with your comment there, is that people, even poor people, eat too much meat. They're not getting the $13 steak, but they're getting the ground beef and, you know,
exactly,
this expensive stuff. And it's destroying health, right? It's associated with overweight, eating too much, not eating plants. It goes against the dietary guidelines for Americans. So I think it'd be, if you have to pick one or another, I would pick a whole foods diet. I would pick a vegetarian whole foods diet over an American meat diet, just because we've got this long history of cardiovascular disease and colon cancer, which is relevant as well. So it's just people, you can go to, and I don't go anywhere anymore, but places like Walmart, you can get these giant buckets of ground meat, right? So it's pretty cheap.
Yeah. The 70% is like, I think like $3 for like that little pound roll, but the 90 to 97% lean is, upwards of $6-7. Mm-hmm. And that right there is like such a big difference. It's like double the price.
And with time, like you had mentioned, I mean, that's why people are so gravitated to keto. They're like, well, I can go through the McDonald's drive-through, pop the buns off, and then just be eating healthy. And that's, and I've heard that before. They're like, wow, I can still eat out and I just take the buns off. And I'm like, but.
Can I take a survey? How many of y'all are vegetarian or pescatarian maybe? Cool. I was just wondering.
Okay, well, thank you guys so much. This has been a really fun discussion. It was a fun way to get people thinking about these things, and the presentation was great too. So we are, I like your little clappy hands. That's cute. Oh, Lordy. Oh, is that a reaction thing? Okay.
Yeah.
Okay, y'all just ruin the rest of my presentations for the semester. Thank you. Have a great day, and we'll meet next Monday. Same thing.
Thank you, Dr. Patel. Thanks, everyone.
Okay.
Bye.
8 a.m. is perfect.
All right. Take care.
Bye, everybody.
Bye.
See ya.